Hello everyone, in this example we are asked to evaluate these four inverse trig expressions. So we'll start with sine inverse of 1/2, evaluate that. Then we'll talk about arcsine of negative square root of 3 over 2, followed by sine inverse of 2, and this weird composition we'll end with arcsine of sine of 3 pi over 2. Alright, and so the thing that we're going to have to keep in mind while we're evaluating all these expressions is that sine inverse or arcsine has a range of negative pi over 2 to positive pi over 2, or if we take that to the unit circle, the angles or arc lengths we're going to get out of these inverse sine or arcsine functions are going to be these angles or arc lengths on basically that right half of our unit circle, with the arc lengths or angles being from negative pi over 2 to positive pi over 2. So we have to kind of relabel those lower angles in the fourth quadrant. Alright, so the first of the expressions on our list that we are asked to evaluate is sine inverse of 1/2. And so to help us evaluate sine inverse of 1/2, we're going to use the unit circle over here to our right. But we also want to keep in mind exactly what is going to come out of this function. And so we have to remember that our inverse trig functions are always going to output these angles or arc lengths. So the output of sine inverse of 1/2 is going to be an angle or arc length, theta, right? That's what we usually use to note our angles or arc lengths. Let's go ahead and call that theta. So it's going to be a special angle or arc length theta such that our output or angle theta is between negative pi over 2 and positive pi over 2. And it's true that if we were to take sine of our angle theta, we would get the value of 1/2. That's essentially just going back to the definition of what it means to be an inverse function. The inputs and outputs switch, but we have this extra caveat here with our inverse trig functions is in that we had to restrict the domain to some smaller interval to actually make it a one-to-one function and have this inverse trig function in the first place. So now we're going to go back to our unit circle and think about interpreting our sine function. So sine corresponds to a y coordinate on our unit circle. So we want to figure out, where do we have a y coordinate of positive 1/2 on our unit circle? Well, it looks like there's kind of two locations on our unit circle that have this y coordinate of positive 1/2, at least in that first trip around our unit circle. One is in the first quadrant and the other is in our second quadrant. The only one that is going to come out of our sine inverse expression is going to be this one in the first quadrant. And that is because this angle in our second quadrant will not be in that interval of angles or arc lengths from negative pi over 2 to positive pi over 2. So at this point, it's really just remembering, well, what point had a y coordinate of 1/2? Well, that also had the x coordinate of square root of 3 over 2. And the angle that got us there was pi over 6. And so what that means is that if we evaluate this expression, sine inverse of 1/2, the only answer we're going to get is pi over 6. Or if for some reason you wanted to work with degrees, that would also be sine inverse of 1/2 is 30 degrees. Most of the time we're going to be working with radians, but be aware that you can actually change your units here. All right, so next up on our list is this expression arcsine of negative square root of 3 over 2. Remember, arcsine is just our alternative notation for sine inverse. It is still our inverse sine function. And this is actually very similar to the process we use to evaluate sine inverse of 1/2. We're just working with a different point and a different arc length or angle, essentially. So now we're trying to figure out the output of arcsine of negative square root of 3 over 2 is going to be an angle or an arc length. What we know about this angle or arc length is it's going to have to fall on this restricted interval from negative pi over 2 to positive pi over 2. And what's special about this angle or arc length, other than its location between negative pi over 2 and positive pi over 2, is that this arc length has to be such that if we take sine of this angle or arc length, we're guaranteed to get negative square root of 3 over 2 for that sine value. And well, there's 2 points on our unit circle, at least in that first trip around, that has the y coordinate of negative root 3 over 2, but we don't want both of these, we only want one of them. and the only one that is going to come out of our sine inverse or arcsine function is that one on the interval from negative pi over 2 to positive pi over 2. So that's going to be this one down here in our fourth quadrant, and now we have to find the angle or arc length associated with that. So in our standard labeling of the unit circle with all of our angles or arc lengths going from 0 to 2 pi, the angle corresponding to that point in the fourth quadrant with a y-coordinate of negative square root of 3 over 2 is going to be the angle or arc length of 5 pi over 3, but that is not our answer here because 5 pi over 3 is not in our desired interval from negative pi over 2 to positive pi over 2. So what we have to do is instead find that coterminal angle to 5 pi over 3 that it is in our desired interval, and we can always find our coterminal angles by adding or subtracting multiples of 2 pi or the period. Since we are bigger than pi over 2, we are outside and above our range, so we're going to want to subtract 2 pi from 5 pi over 3 in order to find the correct angle, and that's the same as subtracting 6 pi over 3, and that gives us negative pi over 3. So you may have been able to visually see that this angle, if we just go in the opposite rotation direction, is going to be negative pi over 3. But if you weren't able to visually see that, we can always use this concept of a coterminal angle to find that as well. So long story short, we know how to evaluate arcsine of negative square root of 3 over 2. That's always going to evaluate to negative pi over 3. All right, so up next, we're looking at sine inverse of 2. And remember, for the output of our inverse sine function is going to be some angle or arc length. Let's go ahead and call that theta. We know that this angle or arc length theta has to be between negative pi over 2 and positive pi over 2. And furthermore, we know that if we take sine of our angle theta, we get what is inside of our inverse sine function. And so that means we're looking for this angle theta such that sine of theta is equal to 2. And you might scratch your head at that for a moment and hopefully realize this is impossible, this will never happen. Remember, our sine function corresponds to y-coordinates of points on our unit circle, and while the largest y-coordinate is positive 1 and the smallest y-coordinate is negative 1, so that means it is impossible for sine of theta to ever be equal to 2. So this expression sine inverse of 2 isn't possible. We say that that expression is going to be undefined. So if we tried to evaluate something like sine inverse of 2 on our calculator would give us some kind of error or tell us that expression is undefined. Honestly, we're not going to run into this situation too much. I think the most common cases where we'll encounter a situation like this is when we made a typo or a mistake and tried to enter something into our calculator. This will be our indicator that we may have made a mistake somewhere, or when we're solving our trig equations and we end up correctly coming to a situation like this, that might mean that our trig equation has no solution. Not too common of a scenario. The point of that little example was to make sure that we're aware of what we're plugging into our inverse sine function as well as being aware of what comes out. And so for our last expression here, this one is also a little bit tricky because what we have is a composition of a function with its inverse, right? We're looking at arcsine of sine of 3 pi over 2. And when we first learned about functions and inverse functions, one of the facts we learned was, well, whenever we compose a function with its inverse, they undo each other and essentially cancel each other out. And it really doesn't matter the order of this composition. They always essentially undo each other. And this is still going to be true here, but we have to be a little bit more careful because this kind of rule or statement that was written for general inverse functions assumed that all of those functions were one-to-one from the get-go. We know for our trig functions, they were not one-to-one from the start. We had to restrict their domains. So that means we're going to have to be a little bit more cautious as we proceed with these types of compositions. So what I'm trying to say is we don't want to be too lazy here and just cancel out arcsine with sine and say our answer is 3 pi over 2. We can tell that that's not going to be right off the bat because, well, what comes out of our arcsine function is always an angle between negative pi over 2 and positive pi over 2. So there's a couple different ways to reason through and evaluate this expression. One is to essentially do that cancellation, say, well, we get 3 pi over 2, but that's not in our range. So now we have to find a coterminal angle by adding or subtracting some multiple of 2 pi from 3 pi over 2 to get our answer. That'll work. Or we can just evaluate our composition from the inside out. We'll get the same answer either way. So if we do this evaluation from the inside out, what is sine of 3 pi over 2? Well, we can go back to our unit circle, go to our angle or arc length of 3 pi over 2. That points us to the bottom of our unit circle, and sine is pulling off that y coordinate. So that'll give us -1. So now arcsine of 3 pi over 2 is totally equivalent to arcsine of -1. And now we can evaluate arcsine of -1 using our unit circle. And that's going to be -pi over 2, because what comes out of arcsine has to be that angle, where if we take sine of that angle, we get this number, in this case -1, and that angle or arc length is -pi over 2, not 3 pi over 2, because of our restricted domain issue. So like the previous example, we're not going to run into these compositions of inverse trig functions with regular trig functions too often. We will see them occasionally, and we'll have to be careful in how we simplify them.